Yeah, so today we're gonna see chapter 5, which is basically titled Inner Workings of Python Objects. So we know everything in Python is object, right? So this chapter is basically trying to let us see what are these objects, the inner working of them. Um, um, as a programmer, it's not necessary, as I said, to know the details of this part. You can do your programming detail, but it's good to know what happens behind the scene. So that's why this chapter tried to look up some of this stuff and try to explore them so that you should know what is happening. But yeah, so that's basically the so the first one, we know what dictionary is, right? So dictionary, we know, is one of the data structure in Python that a container for object that is used to contain mapping of some stuff. Like, for example, we have name, this, share. So this is dictionary. So dictionary actually plays a critical part, not only for storing real life values from but internally in the compiler, it actually in the interpreter, I mean, it's actually useful to store some object, as we see. So now you can see this is a dictionary. So dictionary, this kind of way of arranging data in dictionary format, that is the value, key, and value is useful for interpreter, as we say. So the first way thing we should say is how dictionary and modules work. So we all know that a modules is basically a simple Python file that is import is saved with the PY is called module. So here I have a simple um, uh, Python file. I say x equals to 2. I have a function called bar and I have a function called spam, and it's not doing anything. Just you can see I put spam. I just save it with the POI. So this is basically a module, right? So a module is that. So let's look at how dictionary, what is used useful. So what is happening here is that a special attribute of every module is ticked. This is a dictionary containing modules properties. So let's import this module. What I saved here, this one, I import it here. And now when I import here, you can see here I say foo, that is the module name, underscore danda dick, right? So what this is, basically it will contain every attribute which attribute to this object module, because everything is object in Python, even the module is object. So every attribute that relates to this object will be listed here. So even the name is here, and you can see here some of the attribute of this module is that it has some functions, bar and spam. So you can see that when we call this, you can see if you go down here, you can see like we have attribute x equals to 2. Yeah, if you see we have this module has attribute x equals to 2 and these functions. So we can see here the attribute, the functions. You can see this is a function foobar, this is a function. So basically we can see that this underscore date, it basically return all the attribute related to a particular object in Python. So that's for the module. What about any object? So we have seen now what it contains in module. So it is something also for any object in Python. So not only module, but also any object we have, we instantiate, for example, can have such kind of stuff. Let's look at an example. So this is a class called stock, and we define it has 3 interests: name, share, and price, and we assign these guys here. So we can see here we have a class called stock, and we can actually instantiate an object called s with this attribute, 3 attribute inside. So we can see here we have our x, and now let's use this dig on this object, right? So this is an instance, right? So we can call this method, this dict on it and see what will happen. So when you call the, you can see it basically returns the everything related to this object, because this object instance has name, good, has shares 100, has this. So it will return basically this stuff from that. So that's basically what this work, how it shows in an instance. But we can also have this operate on the class name. So we can see here, this is a class name called stock, and we can call this dict on this class name. And we can see when we call this guy, it will give us like everything inside. It say, okay, there is a init method here. We have the init method, this the init, and it tells us a lot about stuff. Some this, all this one, they are default that are found by the normal class. So each instance gets its own private dictionary. So what about if, for example, here, I use this class to create many different kind of instance or different kind of object? What would happen? So you can see here, I use X again, I use T. So here you can see I use different object, right? So T will have its own private attribute and also S like that. So when we run this guy, we can see here when we say, okay, t.dict, so you can see it gives us this. When we say also s.dict, it will also give us this. So we can see basically this underscore dunder method. Basically, what it does is that it actually carries also all the attributes related to our particular object. So that's what it does. So for example, we know this is a list, because list is also right. I'm going to show this example. List keyword, list is a keyword in Python that can be used to create a list, right? So every function in Python are objects. So this dict keyword method can also work on any method. So we can call this guy here, and we can see some of the built-in object, built-in properties of list, which, for example, you can use list to set item, add, multiply, contents, or all these are attribute, clear the list, for the list method, right? But not only that, we can also call on it on tuple. So we can see here also, it basically gives us the same kind of stuff like hash, all these are attribute or method that relate to tuple. So this is basically something that you can observe while you are doing your programming. You want to see what kind of attribute actually relate to this object. So you can use this dunder method to find all the attributes related to particular object. Yeah, so that's about this dunder method dict. Yeah, Taylor, you want to add something?
No, but I did like the part where you could see the methods for list and tuple. I just thought that was neat. That you see like the underlying stuff.
Yeah. Okay. Right. So okay, cool. So right. So this is the next session that discuss about class members. So let's look at what this means. So a separate dictionary also hold the methods. So let's look at this is a class called stock, and we have method cost, and we have a method cost. So we can call this also right. So this is what I've already shown, that we can actually have the this dunder method on the class. I've already shown that. But the next thing here is attribute access. So we know we can access attribute of class using dot notation. We can assign attribute value to the attribute using the setting. We can also delete object name. So this is something we already know. Here we can say, okay, what is S name? That is the object name. Is good that we already assign, and we can use this to assign a new value to the object. And now when we call X name, we can see it is by. We can also delete the object at all. So this is something we should know, that given a class, we can create an object using dot notation. We can assign a value, new value to that object using the value in the right-hand side and assign it here. And we can delete the whole object using notation. Yeah. So right, so that's basically the exercises for this session. I didn't manage to do that because I tried to do even the stuff late today. So yeah, we can just see do you manage to go through the exercise, Stella?
No, I read through them, but I didn't finish them all.
Okay, you didn't manage to go through them, right? Okay, right. So how inheritance works. So the next session will discuss about inheritance and how it works. So we all know, Tella, in your previous session that we did classes, do we discuss inheritance?
Yes.
Okay, yeah. So so classes may inherit from each other, as we know, but as we have seen this underscore dunder method for the tick that store the attribute. Now here we have another dunder method called base. So if we have inheritance, this dunder method base tells us the base class that the child inherits. So let's look at it. So here you can see I have a class called stock, right? And now here you can see I have another class called price, right? And here you can see I have stock B, which basically inherits stock and price, right? And we can see it here. So this is a class stock B that inherits this. Now, if we want to find what classes stock B inherit, then we can use this dunder method basis. It will shows you the basis class which it inherits. So when we run this guy, we can see that it inherits from stock and it also inherits from price. So that's two things we now see. We have seen a dunder method dict, which basically contain the attribute related to an object, and that object can be either a class, an instance, or a function whatsoever. When we say object, we mean everything in Python, because in Python, everything is object, be it a function, be it a class, be it a number, everything. So you can call that dunder method to inspect that. And the next thing we see just now is the basis, right? So basis is basically another dunder method that tries to shows you what in classes a particular class inherits. So that's two things we learned today concerning what is called dunder method. I think the next chapter, the next week, will certainly depend or discuss thoroughly about this kind of dunder method. Yeah, so we'll see more for that. Okay, Tella, you want to add something?
No, I don't have anything.
Okay, so the next thing is method resolution order, or MRO. So, some languages support multiple inheritance, while some do not. But in particular, Python actually support multiple inheritance, and how these inheritance now sage if you call a method. So this is what is called method resolution order. Let me explain that. So let's assume here I have a class A, and this class A is nothing, it's doing nothing, right? Just because I use just a keyword pass. Keyword pass is just serve as its placeholder. You can see, yeah. So now here you can see I have another dunder method which is called MRO, which is called method resolution order. Now, when we have a single class and the class does not inherit anything, the MRO doesn't say anything, because what this is saying is that the class A basically search inside this class first, which is basically we have a single class. What about this one? Now we can see here we have class B, and class B inherit from what? Class A, right? So we can see here class B inherit from class A. Now when we run this method, this dunder method, we can see that the MRO, we have the class B, then go class A. So what this MRO means is that when you call this class, the Python as you can see here, what they say, the order in which base class are searched when looking for a method is often called. So which order now the method will be searched? So if we run this class, if we run this class, the order in which method will be searched will be, it will start from class B, then it will go to the class A. It means it will run every method that are inside B first, then go, if it finish working with the method inside B, then it goes and execute method inside A. So this is the meaning of MRO. That is the order in which method, the order in which base classes are searched when looking for a method is often called the method resolution order. Yeah, so this is just what this means. So you can see here, it's not something that programming that we see, but it's just telling you the inner side of Python, what is actually happening behind the scene. So yeah, so we can see also here, this is an example. C, it inherit that, and where I call C underscore, so it will basically start searching for class C, and now after that, it will now go for class A. But we can see here there is something called object, because everything is in Python is object. Then it means it can inherit from object. So here class A, we have this. We can also have something like this. We can say, okay, class A, because everything in Python inherit from object. Then we can run this guy. This is still the same thing with the previous one. So that is why when we run the single one, we can see object. It means A inherit from object. When we run these guys, we can see this also, we can see object. So every class inherits from object, because object is the basis for the building block. Now, this is the interesting part where we can see how these classes are such. So because we can see here, we have class A, right? We have class A, and here we have class B, we have class C, we have class D, and we have class E. Now, you can see that class B actually inherit from A, class C inherit from A, class D inherit from the B, and E inherit from D. Now, how Python actually search for these classes? So Python pre-compute an inheritance in chain and store it in the MRO. So Python will compute the chain, it will search these classes and store in MRO attribute on the class. So let's look at what will happen now here. So the rule is devs first. What we mean by devs first is that it will actually start looking for the depth last one. So it will start searching for the last one. Then which one is the next? We have D, right? And which one is the next? We have C. But we have C, but it didn't show us C, it only show us B. Then it goes and show us A, which is the main class, and now it shows object. Now it means if we look at this one here, the C is not depicted here, right? But if we look at something, class B actually inherit A, class C actually inherit A. So they inherit the something. So why is this? So if you look at this, is what it says. If any class was duplicated in the search, all but the last occurrence will be deleted from the MRO list. So this means that this guy, the A, okay, we have after D, right? D, we should have after D, we should have C, right? We should have this. So the Python basically deletes it. Only the last one, which is not repeated, will now be will be allowed to be shown in the MRI list. So this is basically what they mean. So if we have any duplication, even if it is 10, they will all be deleted. Only the last one will not be deleted. Yeah, so this is basically, now we have seen another one, which is basically MRO, which basically means it shows us how method is called method resolution order. It shows us basically the order in which base class are such, so that function and other method can be executed. So that's basically now the third one we have seen. So we have seen now 3 Dundas method, but MRO in multiple inheritance. This is actually where the multiple inheritance, the MRO shines. It shows the power. So what is happening? So let's look at this guy. So here you can see we have class A, we have class B, but here class C is multiple inheritance, right? And we have class D, and now we have class E, which is multiple inheritance. So what will happen now? If you remember previously, we just move around depth first, this guy, then this guy, it leads them in this order, right? In this order. But what about this in this case? Now in this case, we have multiple inheritance. It will start with this. Now, then it will go for what? How will that happen? So let's look at what will happen. So if we run this guy, what is it called? Okay, yeah. So the first one, as we can see, is E, right? Is E. So let me call MRO underscore it. So this is what we have. So what is happening is this. There are 2 rules. The first one is children are always checked before parent. So we can see here, E is a children, right? D is a children. C, children are always first checked, and parent, if multiple, are always checked in the order listed. So parent are also listed in the order listed. So in this case, we'll start checking with E. So you can see E is listed. But then the next one here is that before we go into this one, it means we have a parent. So before you finish this child, you must search through its parent. So C is checked. So here you can see C, right? And where is C? So you go for class C. This is class C. So you can see class E, then you C, you go class C. This is class C. But inside class C, you have another thing, which is A. It means now you call A. So that's here we have, you can see class C, main A. Then you now finish with C. Then you go for D. Then here we have D. Can you see that? And now after we finish with D, then we go to the next class, which is D, which is this. Then D calls for B. Then we have B as well, which is this. So this is somehow kind of nested stuff. But the main idea is this. Children are always checked before parent, and parent, if multiple, are always checked in the order listed. So this is basically one implementation of algorithm called C3 linearization algorithm that implement this. Yeah, so this is basically MRO, which is basically we will not be using it in day-to-day code, but it's just trying to let us know the intuition, what is basically happening under the hood. Yeah, Taylor, do you want to add something?
No, but that's something that I've never had to use or even think about. So
Taylor, do you want to add something?
No.
Okay, all right. Okay, so let's move on to next one, code reuse involving multiple inheritance. So we know basically inheritance allow us to in some ways avoid duplication of code. So let's look at an example. So this is a class called dog, right? This is a class dog. It has some, method called noise. It has some method called chase, and it has some there's another class called loud dog, right? But it inherits some features, inherit properties from dog class, and now we have another method called def noise, and we said return super noise upper. So what this means is that super, this is a keyword. We say super noise. This is telling you want to override the so if you look at this one, we have the noise here, right? We have the noise here, which is a method, but here we use something called super, and will be explained later in a bit. But let's see what this will return. Then we have another thing, the same thing, which is called class bike. It has noise, pedal, and it has something like this loud bike, right? Now, one interesting thing we can see is that this method, they are the same, right? This guy in this class, right? Class dog and bike, loud bike, they are the same. Now, can't we actually come up with an approach where we can say, okay, we can use this class, we can use this class, and we let these two classes share this commonality, this code and this code? How can we because it's more or less the same thing exactly. Now, how can we let them share them? Because it's really redundant to write the same thing multiple times. So this is where there is a code commonality here. Repeating some code is not efficient. So this is what we will see that is introduced, which is called mixing pattern. So mixing pattern is basically provide a method of implementation for use of multiple related child classes, right? So related child classes. So if you look at this guy, this is a child class of class dog. This is a child class of class bike. Now, mixing is a class that provide method implementation for use by multiple related child classes. However, the inheritor is not implemented and is. So this is a method that can be used to implement for related child classes. So let's look at what we mean. So this is the method class dog. This is a class dog, right? This is the class bike, right? And these classes, they have the child method called loud bike. It has a method called loud dog, but they're just loud. So we can create a single method class called loud. Can you see the class loud? And now it is everything, right? So now what is this class? Is it different from these normal classes that we know? That's a good question. With these classes, when we create a class bike or class dog, I can basically create an instance, right? So a mixin does not define a new type. So a mixin, this kind of class that we normally take out if it shares some commonalities, it is not used to create a new class. It just, a mixin bundled a set of methods for use. Each mixin should have a single specific behavior. So this is the mixin. This is a class that will mix with this class and this class. So let's look at what will happen. So you can see here, I call class loud dog, right? And now I say, okay, loud, it inherit this method loud, and this class loud, and inherit dog. So that is for the dog. Now for the bike, I say class loud bike, loud, the same class and bike. So we can see here, we now actually, instead for us to have this kind of duplication in each class, in each section code, we have this duplication. Now we actually perform deduplication. We have only single class, and now this single class now is inherited by a method called and class called loud dog, and it inherits both the dog and now this loud. So we can see here, if I have this loud dog, I can see here if I call noise, you can tell me the back, right? Now also if I call the chase, because these are all part of the dog, because dog, they inherit all the property of dog. So which are the chasing and the barking. Now also for the bike, we have the noise method, and also we have the, so you can see for the net on your left, and also we have for the pedal, when we call this property, it gives us the pedaling. So we can see all these properties, they are basically inside the each class. So for bike, we have the noise is on your left. For pedal, we have pedaling. For noise, we have bark. For dog, and for dog as well, we have chasing. So when we say super here, we means use the noise, this noise from the super, from the class, from the class you inherit. So here it means when we are gonna use this, when we're gonna call loud, this super will use everything properties from from the dog. So that's this super. Yeah, so loudness was now implemented just once and reused in two completely unrelated classes. This sort of trick is one of the many primary, so this kind of trick is used basically to try to deduplicate code so that you have a single representation. Yep. Taylor, you want to add something?
No, I think that's pretty interesting, but I also feel like I would mess that up. So I'm not sure I'd ever use a mixin pattern.
Yeah. Okay, cool. So this is super, as I already explained it, is basically used allowed to build classes that let me show an example for that. So let's look at this an example. I have a class called computer. I basically have the name of the class called computer and have some kind of attribute instantiated. And now I have a class called mobile, which inherit from computer. And we can see here I have computer, RAM, storage, model. But here I say super init computer RAM. So it means this guy super it inheriting this this attribute from the main from this class, from the computer class. So this means that all these computer RAM storage for the mobile phone will also be the same thing. So this is the essence of super. So when we run this guy, we can see here we instantiate an object called Apple. We call mobile here, and we can see here we put this stuff, and now this will give us this. So this is basically the attribute. Right. Then the next session called classes and encapsulation. Right. So we all know that Python actually everything is public. There is no private stuff in Python classes, right? So how can you actually indicate something is private so that there is no accidental manipulation or change? So this kind of issue with Python that everything is public, there is some issue toward that. In Python, almost everything we know is about class and object is open. You can easily inspect it. You can change anything. There is no notion of access control. So everything is public in Python, but how can we show that something is private? So Python actually relies on something based on convention that shows something that is private. Unlike other programming like C++, where you can say public, if you want to create a class, you use a public keyword. If you want to create a private class, you use a private keyword. That means the private class is not accessible outside the world, only the public class. But in Python, you cannot have public and some stuff like that. So let's look at what we mean. So here we have a class called Python, and now we can see here we have the name of the person, we use underscore and assign them. So what this means is that name is private, but that is just a convention because Python there is no notion of private and stuff like that. So you can see here when I assign the new name, I call this name. You can see that it gives me video, and now I can asset the attribute. I mean, I can change it. So you can see this means it's not private. I can access it, meaning that I can see the name, right? And I can even temper it, change its value. You can see I change. This means that there is no notion of private here, object, private object, because I can access it and I can change its value. So you can see as a general rule, any name with leading this is considered internal implementation, whether it is a variable, a function, or a module. If you find yourself using such names directly, you are probably doing something wrong. So this means that in Python, you will always sometimes see variable or some function names with this underscore. Don't mess with them. They are basically some kind of implementation, internal Python implementation. So they are private. Don't use them, don't tamper with them. That's basically the notion of private stuff in Python. You want to add something, Taylor? Or should I go?
No, you can keep going.
Okay, so we have simple attributes. So another thing here we can see that yeah, so let me run this guy. So here we have a class called stock, and now these values here, the attribute names and share and price, we can actually assign a new value to them, assess it, right? For example, here, you can see here the share here, right? Share. I assign a single digit number, which is 100. That's fine, right? But also here, the same stuff, I assign the share attribute 100, a string. That's strange, right? Because a share is a number, right? But here we assign a string. Oh, we need to do something. In fact, to make it the matter worse, you can see here we assign a list to a share, right? Which is not intended. Now, the question is, how can you prevent tampering the attribute in a class so that they received intended value? How can we make sure that share is a number, that share is not a string, right? So in that case, for us to do that, we can implement them in some possible ways. So yeah, for example, if we try to assign a string, can we show an error? So there are many couple of ways for us to do that. One approach is introduce Assessor Method. So this is basically, so you can see this is the code previously. This is the code, right? This is the code. We assign the name, we just receive share, we assign them here. Normally we define, but one way is to introduce what is called Assessor Method. So you can see here, I have what is called set share. So this value actually will collect the items, the attribute, and share it. So set share. So here you can see I call it. So set share, it will receive a value, and we check if not, it's not an integer. If it is a string, the raise type error. Else return that value into share. Right? Can you see share? So set share actually returns a share. So you can see here, when I have a share, I now use this method, set share, I now input the object. So this means that set share, the value here, which is share here, what will be returned is the value that has been imputed. So you can see here, instead for me to call this, to use this directly, to assign the value as it share, just this share directly to assign it to the object, to the variable share. No, we want to make sure that that value is integer. Well, how can we do that? We need to create a separate function called set that set the value, a separate method that set the value. And that method will, inside that method, we will try to check is this the object we intend to receive? If not, there is an error. So this, you remember, every method has a self, and this is the value that the share. Now this, if not an integer, read this error, else return the value. So it's set here. And this is get share, which basically we return the as well the share. So we can see when we run this guy, basically the something. But the drawback here, okay, I don't know. But the drawback here, we can see that too bad this break all our existing code. The drawback here is that we need to change this to create something set share. Instead, what about if previously we have all our code looks like this? It means we need to go and break them and change them. So what's a better way that we don't need to tamper with our names, with our variable here? Just we wanted them to be natural the way they were before. So this is alternative approach using property. So property is a decorator, is a Pythonic way used for getters and setters in object-oriented programming. And let's look at what happened. So here we can see we have property, right? We have property, right? So here you can see the same thing. This our object variable, they are name, shares, price. We don't touch them or using any method, set method. No, this is the beta, but we use something new called property right here. So here I have property, and because it's share, I say share self return self share, right? But here I have set share, so shares at here the setter. This is a setter method that set the value. The same code we had before. This guy, the same thing here, right? But what happens, what differs here is that we use this property and now we use this one, share setter. So if you look at this one here as well, yeah, okay, yeah. So what this means is that we are using something new property here and this. So the normal attribute access now triggered the gather and this at this set here. With this button, there are no changes needed. So with this button, no changes needed. But we introduce this. This is a property, and this is what we call Danda method, not the decorator, and that will be the next session, and we'll discuss about this more. But for today, we can say that this for you to do that, you can use the property and a setter. This will basically set your method and do the share here. You can see that and without actually modifying this. So we can see here we can do normal classes object. We can you can see here it shares the this guy, right? So also property, a property internally use a private name like this. The rest method of the class can, so you can see here we have something here. So here we can see the share is private. We use, and this is private. We said this our object is private, but this private object, we can use it in other stuff like other method without identifying whether it is private. We can use it just the way it is. So yeah, so that's something we should know. But there is one thing we should also know is that properties are also useful for computed data attribute. So this property, they are also useful for computed data attribute. This allows us to report extra parameters. So let me show you one example why this is useful. So here I have a class called stock with everything we saw. And now I have another method called cost. What is this method doing is that it takes the attribute here, share, and it takes the price and multiply it and return the value, right? So that's what it's doing. It just takes this guy and this guy. This method is doing computation, right? Computing something. But these properties are also useful computed data attributes. Now you can see this is computed data attribute. Now we know if we want to, so here you can see here before this method, I call this property. I call this one. So this property is always called before the method definitions. So because this is basically calculating the properties, it's not assigning value, it's not doing anything, it's just calculating. Computation property are useful for computed data attributes. So now let's look at what will happen now. So we can see here, this is a stock. I create an object, right? S.share will give me the share, which is 100, right? But now S.cost, we have a method called cost. But we know if we want to call a method, we normally use break this, right? But if you use computed values, you call property on the computed value, it's not necessarily that you put this method, this one. So I can just run this guy. Can you see that? It will return the computation here, this times this. So it means this value times this value. So you can see here, property is now used for computed property, for computed attribute without explicitly using the brackets. So you can see the assistant is known as decorator. It specifies a modifier that applies to the function definition that immediately follow, and which will be the discussion for the next chapter. So that's about that. The last thing we see is what is called slot. And because this chapter session is basically talking about how can we prevent accidental manipulation or changing of classes object. So there is another Dunder method called slot, which basically restrict given an attribute that is not specified in a class. So for example, here I have class stock, and now I have slot. And in the slot, I name shares price. This is telling us that the class must have only this method, object, man share, and this guy, only these ones. If you try to modify or you try to add another element that is not part of this slot, it will generate an error. So that's at the end of this session. I unfortunately haven't tried the exercise because of the time factor. But this is an opener to the next session, which is about decorators. And yeah, so that's all I have got. Tella, anything you want to add?
Yeah, do you know if and right above this, when you're using the property decorator, we have like @ shares dot setter. Does that always need to be @ name of property dot setter, or can that be called anything?
Where you mean here?
Right here. Yep.
Okay. What do you say? What's the question?
Do you know if that line that you're on, where it says @ shares dot setter, does it need to be @ then the value that you're looking at dot setter, or can it be called something else?
Okay, so here is a property here, then share self return self. Is it the question here?
No, it's the next section down.
Okay, this one. Okay, what the question is?
So it says @ shares dot setter.
Yes. Okay.
Does it have to be @shares dot setter? Like, is it the dot setter at the end that makes it work, or?
Okay. Yeah. So so here is the getter, and here is the setter. So I think if I understand it correctly, so you can see here, this is the getter, right?
Yeah.
So, and this is a setter as well, which is basically the assessor method. So this get share here we can see is this get method that basically return the share as well. But here we can see that this is the method that set the any value that we input to a share. Now, if we want to use this one, I think I'm not quite certain, sure, but I think maybe in the next session we'll have, because I've not read much about decorator, but all I have is that the intuition, they looks the same, that we need to have the getter method here as well. And now the question you have, like the setters, will it be the same thing, like we need to say share the setter? So the question, I think I'm not 100% sure that, but I believe the object we want to assign, we set it here. That is the share, which is this one here. We set it here. So share the setter, it means this is what is setting what the object share. But I think we can explore this maybe in the next session in more detail.
Sounds good.
Yeah, right. All right. So yeah, thank you for joining. By the way, I think we see next week, and it will be more about these decorators and a lot of, yeah.
Sounds good. Thanks for leading.
Okay, thank you very much, Tella, and see you next week. Bye-bye.
Yeah, see you.
See ya, bye.